Hey guys, calculus class is just about to begin. Oh hey kids, didn't see you there. Being a teen is hard and all, especially when you're in calculus. You know, there's a lot of temptations flying around, and I'm not talking about drugs or alcohol. I'm talking about taking bad shortcuts in calculus.
Hi, my name is Jamal. Dropping the C has ruined my whole life. And my calculus grade. I lost my basketball scholarship too. What you should know from this long and sad story is you always have to add a C after finding the integral.
Calculus can be so hard you gotta stretch. So let's say you've already started making these mistakes. Well, if your life's falling apart, don't worry. There's still hope. Join hundreds and thousands of millions of people just like yourself. Learn from real life examples like the classic root beer still problem.
What in Sam hell? My root beer seems to be leaking. Professor! We have a problem.
You got a problem? Oh, that's my best student right there. He'll help you out with that real good.
Real good. Can you help me with my root beer problem?
I sure can. Hand me that napkin over there. Sure. Okay, see? First we have the dimensions of the root beer keg, and it seems that it has a radius of 20 centimeters and is leaking at a constant rate of 25 centimeter cubed over the amount of seconds. So write that down, team. Now we got to find out the rate at which the height is changing, which can be represented by dH over dt. Now we got to find an equation that fits this given situation. The volume of the cylinder is pi r squared h. We want to take the derivative of this, which is dV over dt is equal to 2 times pi times r times the derivative of dr dt times h plus pi times r squared times dH over dt. Okay, now we got to plug in our values. So it's changing at a constant rate of negative 25, which is equal to, this part doesn't matter because this part, the radius isn't changing, so it's a 0. Then you got to add pi, and then r up there, shown as 20 squared, over the rate at which h changes, which is dH over dt. That's the variable we're trying to solve. Now we have the equation right here. We can solve it. So it's negative 25 is equal to 400 pi times dH over dt. Then we're gonna isolate the variables. So it's gonna be dH over dt is equal to negative 25 over 400 pi, which we can simplify this part. So now it's dH over dt is equal to negative 1 over 16 pi. And that's the rate at which your height is changing.
Well, that's fantastic and all, but how in Sam hell is that going to fix my hole?